Okay, boys, so what we have here is a pickle jar, and it'll only work with elastic pickles. Don't try it with any other pickle jar, it won't work. And it's water. It's just colored a wee bit with cranberry juice. Take my word for it. There would be no point in lying to you, otherwise this video would be pointless. So it's in a jar. It's vacuum tight in the jar, or pretty close enough for our purposes. And what I'm going to do is I'm going to prove the point that by putting this under vacuum. Oh, did I show you the temperature? Let me show you the temperature. It's going to vary as I go up and down the jar here a wee bit, boys, but it's 70-ish. Let's call it 70 on average. Let's see if I can boil it. And it boils. As you can see, I've got it boiling at, let's see when it's boiling. Starting to simmer down at this temperature. Anyway, it's boiling in and around the, let's call it 17 inches of mercury, right? That's not the point. Let's keep an eye on this as it continues to boil its temperature. This might take a while. I might need to actually speed this up. Okay, well, what was the point to that? Well, let's just take a baseline reading. I'll try and keep the glare of the lights. So this is quite a few minutes after the fact here, boys. Want to boil it there with a vacuum. But look at the rate that the temperature is actually dropping. Now granted, when it was a wee bit higher, it probably loses heat a wee bit quicker to the room that's sitting at about, I don't know, 25 degrees or so. The differential would be greater, so it would lose its heat at a quicker rate. But look at the rate that it's actually losing it now. It hasn't moved a tenth of a degree, right? So what's the point? The point is, when you lower the pressure and you lower the boiling point, in order to transition from a liquid to a vapor state, you have a phase change. It takes a massive amount of heat energy. That is the latent heat of vaporization. That is the secret to how your air conditioning actually works. Because there's a massive absorption of heat energy transitioning from a liquid to a vapor state, that's what allows your air conditioning evaporator core to absorb the heat energy that's either in the cabin in recirc mode or from the outside into your cabin. It's that extraction of the heat energy which is required to boil in the case of the air conditioning system, clearly it's the refrigerant, the R134A, or in your cars I guess it's R1234YF if I've got my numbers right. And it's that change in state, that massive absorption of heat energy in order to transition from a liquid to a vapor that allows the air conditioning to actually work. Now, I'm under vacuum here, just using my hand pump, but essentially your compressor does the same thing. So I thought that was worth pointing out. Super interesting. To change from a liquid to a vapor absorbs a massive amount of heat. And keep in mind, we have to cycle this from a vapor back to a liquid in the condenser. And if you were to go from a vapor to a liquid in the condenser coil, it will expel or reject a massive amount of heat. Absorbs in the evaporator, rejects in the condenser. So ultimately you have to dump the heat somewhere, right? So the heat from the car is going into the refrigerant. The compressor compresses it so it can dump the heat energy into the condenser. By condensing from a vapor back to a liquid, it dumps a massive amount of heat energy to the outside of the car where it's less objectionable, and then of course the whole system just continually circulates. That's how it works with a pickle jar and cranberry juice.